On August 15th, 1977, a radio telescope in Ohio detected a signal from space that matched every theoretical prediction for what an extraterrestrial transmission should look like. The signal lasted 72 seconds. It appeared at the hydrogen frequency, the most logical place for an intelligent signal to be sent. And after decades of listening, it has never happened again. This single burst of radio waves remains one of the most tantalizing and unexplained mysteries in the history of astronomy. 72 seconds that continue to haunt us nearly 5 decades later. You're listening to The Drowsy Astronaut, where tonight we explore this famous mystery together, without any rush at all. This video is designed for slow listening, something to accompany you as you rest, drift off, or simply unwind after a long day. Whether you're listening from a bedroom in California or a flat in London, from an apartment in Sydney, or somewhere entirely different, I'm glad you found your way here. If you'd like to share where you're listening from tonight and what time it shows on your clock, the comments are always open. And if calm explorations like this help you unwind, a like or subscribe genuinely helps this channel continue. Now let us begin with those remarkable 72 seconds. The signal appeared as a sequence of characters on a computer printout, letters and numbers that represented the intensity of incoming radio waves measured every 12 seconds. The sequence that would become famous read 6EQJ5, with each character indicating a higher intensity than the last, until peaking at U, the second highest value the system could record. This pattern showed the signal strengthening as the telescope's beam swept across the source, then weakening as it moved away. Exactly what a genuine extraterrestrial transmission would produce. The telescope that detected the signal was called Big Ear, a radio telescope operated by Ohio State University as part of an early search for extraterrestrial intelligence. Big Ear was not designed for real-time monitoring, and no one was watching when the signal arrived on that August night in 1977. The data was simply recorded on a continuous paper printout, waiting for someone to review it and notice that something extraordinary had occurred. That someone was Jerry Amon, a volunteer astronomer who had been working with the SETI project at Ohio State since 1973. Days after the signal was recorded, Amon sat down with the printout as part of his routine review of the telescope's observations. As he scanned the columns of numbers and letters, his eye caught the anomalous sequence, and he immediately recognized its significance. Amon circled the sequence with his red pen and wrote a single word in the margin. Wow. This simple exclamation, scrawled in a moment of genuine astonishment, would give the signal its permanent name. The wow signal, as it came to be known, entered the scientific literature and the public imagination as evidence that something unusual had happened on that summer night. The signal's characteristics matched theoretical predictions that had been developed years earlier by scientists contemplating how an extraterrestrial civilization might attempt communication. The frequency, the bandwidth, the intensity profile, all aligned with what researchers expected to see if someone out there was trying to make contact. The match was so precise that it seemed almost too good to be coincidental. Yet the signal lasted only 72 seconds, the exact duration that a celestial source would remain in Big Ear's beam as Earth's rotation carried the telescope's field of view across the sky. This timing was consistent with a genuine signal from space, rather than interference from something on Earth, which would not have shown this characteristic rise and fall. The brevity of the signal left astronomers with tantalizingly little data to analyze. Just 72 seconds of information that has been examined from every possible angle in the decades since. Those 72 seconds contained enough to suggest something remarkable, but not enough to prove what that something was. The frequency at which the signal arrived was perhaps its most significant characteristic, one that immediately caught the attention of everyone who studied it. The signal centered on 1420 MHz, a frequency known as the hydrogen line, where neutral hydrogen atoms emit radiation naturally throughout the universe. The hydrogen line had long been considered a logical frequency for interstellar communication, a natural meeting point that any technologically advanced civilization would know about. Hydrogen is the most abundant element in the universe, and its spectral line is studied by radio astronomers everywhere. If you wanted to send a message that others might be listening for, this frequency made sense. Radio astronomers had designated the region around the hydrogen line as protected spectrum, minimizing human transmissions at these frequencies, to preserve the ability to study natural hydrogen emissions. This protection also meant that any signal detected at this frequency was less likely to be human-made interference. Though not impossible. The WOW signal arrived right in this protected band, at a frequency that seemed chosen rather than random, that matched the theoretical expectations of SETI researchers who had been thinking about how interstellar communication might work. The coincidence, if coincidence it was, remained striking. The signal's intensity was remarkable, briefly reaching a level roughly 30 times stronger than the background noise that the telescope typically recorded. This strength made the signal stand out dramatically from the usual data, creating the spike that caught a man's attention when he reviewed the printout. Such intensity from deep space would require either a very powerful transmitter or a signal that was somehow amplified during its journey to Earth. Natural amplification mechanisms exist. Interstellar masers can boost radio signals, for example, but none have been found in the direction from which the WOW signal arrived. If the signal came from an extraterrestrial civilization attempting communication, the power required would depend on the distance to the source and whether the transmission was omnidirectional or focused toward our solar system. A civilization comparable to our own could potentially produce such a signal if they focused it in our direction. The intensity profile of the signal, rising, peaking, then falling, matched perfectly what Big Ear should have detected from a fixed source in the sky, as Earth's rotation carried the telescope's beam across it. This profile provided strong evidence that the signal came from space rather than from something on Earth or in low orbit. The narrow bandwidth of the signal was another characteristic that made it unusual, far narrower than most natural astrophysical sources produce. Natural radio emissions typically spread across wide frequency ranges, while artificial signals can be concentrated into narrow bands that stand out against the natural background. The WOW signal's bandwidth was less than 10 kHz, remarkably narrow for any cosmic source. This narrowness suggested an artificial origin, something engineered rather than natural, though the possibility of an unknown natural phenomenon could not be entirely ruled out. SETI researchers had long expected that any intentional interstellar signal would be narrow-band, concentrated at a specific frequency to maximize detectability. The WOW signal matched this expectation, displaying the narrow bandwidth that theory predicted. Every characteristic of the signal, its frequency, its intensity profile, its narrow bandwidth, its 72-second duration, aligned with what scientists had hypothesized an extraterrestrial signal would look like. This alignment made the WOW signal impossible to dismiss, even as it remained impossible to confirm. The scientific response to the WOW signal was immediate and sustained, with researchers recognizing that the observation demanded follow-up investigation. Within days of Ayman's discovery, Big Ear was pointed back at the same region of sky, searching for a repeat of the signal. No repeat was detected that day, nor in the weeks that followed, nor in the years of searching that have continued to the present. The signal appeared once, announced itself with those 72 seconds of data, and has never returned despite the efforts of observatories around the world. This lack of repetition is both the signal's greatest weakness as evidence and its most haunting characteristic as a mystery. Without repetition, the signal cannot be verified, cannot be studied further, cannot be definitively explained. It remains a singular event, frozen in the data from that August night. The WOW signal continues to occupy a unique place in the history of SETI, neither confirmed nor explained, neither repeated nor forgotten. It haunts us because it almost answered one of humanity's deepest questions, and then withdrew into silence. The summer of 1977 was unremarkable in most respects, a season like many others, in the small college town of Delaware, Ohio, where the Big Ear radio telescope had been operating for years. The telescope occupied a flat expanse of land at the Perkins Observatory, its aluminum surface reflecting the summer sun by day and collecting radio waves from the cosmos by night. Big Ear was not an elegant instrument by the standards of modern radio astronomy, but it was dedicated and persistent in its search for signals from space. The telescope had been conducting SETI observations since 1973. 4 years of patient listening that had produced no confirmed detections of extraterrestrial signals before that August night. The observation program ran automatically, with the telescope fixed in position while Earth's rotation carried its beam across the sky like a searchlight sweeping slowly across the heavens. Each day, the telescope scanned a slightly different strip of sky, gradually surveying the accessible universe, one narrow slice at a time. On the night of August 15th, the telescope was pointed toward the constellation Sagittarius, a region of sky toward the center of our galaxy, where stars are densely packed and where many SETI researchers considered signals most likely to originate. The choice of this region was not accidental, but reflected strategic thinking about where civilizations might exist. No human being was present when the signal arrived, no astronomer watching the incoming data, no technician monitoring the equipment. The telescope operated unattended, as it typically did, with its computer recording the incoming radio waves and printing out the data for later analysis. The computer that processed Big Ear's observations was primitive by modern standards, capable of producing only a simple printout of intensity values, represented by numbers and letters. The system sampled the incoming signal every 12 seconds, averaging the intensity over each interval and recording a single character for each measurement. The scale ran from 0 through 9, and then continued with letters, A representing intensity 10, B representing 11, and so on up to Z at 35. This compressed representation allowed the intensity to be recorded compactly. But it also meant that information was lost. The fine details of the signal's structure smoothed the way into these crude averages. When the signal arrived, the computer recorded it faithfully, printing out the sequence 6EQ-UJ5 at the appropriate position on the continuous roll of paper. The printout then continued, recording hours more of observations before anyone would look at what had been captured. Jerry Amon did not see the signal until several days later, when he came to the observatory to perform his regular review of the accumulated data. Amon was not a professional astronomer, but a professor of electrical engineering at nearby Franklin University, who volunteered his time to the SETI project. His role involved scanning the printouts for anything unusual, any pattern that stood out from the background noise that typically characterized the observations. It was tedious work, requiring attention to endless columns of unremarkable data, but Amon approached it methodically. The WOW signal would have been impossible to miss for anyone paying attention. Its intensity so far above the background that the characters jumped out from the page. Amon later described recognizing immediately that the sequence was significant, that it matched what an extraterrestrial signal should look like. His famous annotation, the word WOW circled around the sequence, was spontaneous, a genuine expression of astonishment at what he was seeing. Amon was not prone to exaggeration, and his exclamation reflected authentic recognition that something extraordinary had been recorded. The moment of discovery was quiet rather than dramatic. A man alone with a printout, recognizing that history might have been made on the paper in his hands. There was no celebration, no immediate announcement, just the dawning realization that this required serious attention. Amon brought the printout to the attention of the project's leadership, and the process of analyzing the signal began. The first priority was to determine whether the signal could be explained by equipment malfunction, interference, or some other mundane cause. The telescope was checked and found to be operating normally, with no evidence of any malfunction that could have produced a spurious signal. The frequency was examined and found to be in the protected band where human transmissions were prohibited, reducing the likelihood of terrestrial interference. The signal's characteristics were compared against known satellite orbits and frequencies, against aircraft transponders, against every source of radio interference that the researchers could think of. Nothing matched. The signal appeared to be genuine, a real radio transmission from the direction of Sagittarius. Word of the detection spread through the small SETI community, generating excitement tempered by appropriate scientific caution. A single detection, even one with such promising characteristics, could not be considered definitive evidence of extraterrestrial intelligence. The scientific standard for such a claim required repetition, independent verification, the ability to study the signal in detail over multiple observations. Without repetition, the WOW signal remained an anomaly, interesting but not conclusive. Efforts to detect a repeat began immediately, with Big Ear pointed back at the coordinates from which the signal had apparently come. The telescope searched for days, then weeks, then months, finding nothing but the ordinary background noise of the cosmos. Other observatories joined the search as word spread, directing their instruments towards Sagittarius in hopes of detecting whatever had produced that 72-second burst. The combined efforts of radio astronomers around the world produced only silence. The failure to detect a repeat did not mean the original signal was not real, only that whatever had caused it was not producing continuous or regularly repeating transmissions. An extraterrestrial civilization might send signals intermittently, or might have been beaming in Earth's direction only briefly. Alternatively, the signal might have been a natural phenomenon of some kind, a cosmic event that occurred once and would not repeat, something that current astrophysics could not explain but that had nothing to do with intelligent life. The ambiguity was frustrating, but also scientifically honest, a recognition that the evidence was insufficient to support definitive conclusions. The wow signal remained in limbo, neither explained nor confirmed, a mystery that would persist. As days stretched into weeks and months without a repeat detection, the initial excitement gradually faded into something more like puzzlement. The signal had come, it had been recorded, it had matched every expectation, and then it had vanished. Wherever you're listening from tonight, perhaps the clock shows midnight where you are, or perhaps the early morning hours, or perhaps it's not yet fully dark. The mystery of what happened on that August night remains as fresh as it was in 1977. The signal came once and has haunted us ever since. The printout with Eamon's annotation has become one of the most famous documents in the history of SETI. Reproduced in countless books and articles, displayed at scientific conferences, an artifact of a moment when contact seemed possible. The original paper, yellowed now with age, is preserved carefully. The night the wow signal was detected was ordinary in every other respect, unremarkable except for those 72 seconds of data that would capture the imagination of the world. Most of the people alive that night had no idea that anything had happened. Even Eamon did not know until days later, when he sat down with the printout and saw the sequence that would define his legacy. Those characters that spelled out something no one has been able to fully explain. The wow signal was not the first unusual signal detected by radio telescopes searching for extraterrestrial intelligence. Nor would it be the last. What made it special was the degree to which it matched the theoretical template that scientists had developed for what an intentional extraterrestrial transmission should look like. SETI researchers had spent years thinking about how a distant civilization might attempt to communicate across interstellar distances. What frequencies they might use, what characteristics their signals might display. The wow signal aligned with these predictions to a remarkable degree. The frequency of the signal, 1420 MHz, was perhaps the most significant match, falling precisely in the band that theoretical work had identified as the most logical for interstellar communication. This was not coincidence, but physics, the natural properties of hydrogen, pointing toward this frequency as a universal meeting point. Every technologically advanced civilization in the universe would know about the hydrogen line, would study it with their own radio telescopes, would recognize it as a frequency where someone might be listening. The choice seemed logical, almost inevitable. The concept of the hydrogen line as a cosmic meeting frequency dates back to the early 1950s, when physicists first proposed that the 21-centimeter emission of neutral hydrogen might serve as a natural beacon for interstellar communication. The idea had been refined over the decades. By 1977, the protected band around the hydrogen line was established in international radio regulations, recognized by human civilization as too scientifically important to pollute with our own transmissions. This protection made any signal in this band particularly noteworthy. The wow signal arrived not just near the hydrogen line, but centered precisely on it, as if someone had chosen the frequency with the same logic that human scientists would use. The precision of the match was striking, suggesting either remarkable coincidence or intentional choice. Natural astrophysical sources do emit at the hydrogen frequency, but they typically produce broad signals spread across many megahertz of bandwidth. The wow signal was narrow, concentrated, focused in a way that natural emissions typically are not. The narrowness of the signal's bandwidth was the second characteristic that matched theoretical expectations, a feature that distinguished it from virtually all known natural radio sources. Natural processes tend to produce broad-band emissions, while artificial signals can be concentrated into narrow frequencies. A narrow-band signal stands out against the natural radio background of the cosmos, easier to detect because its energy is concentrated rather than spread thin. Any civilization attempting communication would understand this principle and would design their transmitters accordingly. The wow signal's bandwidth was estimated at less than 10 kilohertz, extraordinarily narrow for any cosmic source. This narrowness was consistent with an artificial origin, though the possibility of an unknown natural mechanism could not be completely excluded. Radio engineers on Earth routinely produce narrow-band signals for communication, concentrating transmitter power at specific frequencies to maximize range and detectability. An extraterrestrial civilization with comparable technology would likely do the same. The intensity profile of the signal provided the third match with theoretical predictions, rising and falling in the characteristic pattern expected from a distant source passing through the telescope's beam. This profile confirmed that the signal came from space rather than from terrestrial interference. Big Ear's beam was fixed, pointed at a specific point in the sky, while Earth's rotation carried that beam across the celestial sphere over the course of each day. A source at a fixed location in the sky would appear to rise in intensity as the beam approached, peak as the beam centered on the source, then fall as the beam moved away. The wow signal showed exactly this pattern. The sequence 6Q show UJ5 representing the intensity rising from 6 to U and then falling back to 5. The peak at U, representing an intensity roughly 30 times the background noise, occurred at the moment when the beam was most directly aligned with the source. This profile would be nearly impossible to produce by terrestrial interference, which would not show the smooth rise and fall corresponding to the telescope's beam pattern. The profile was strong evidence that whatever produced the signal was far from Earth. The duration of the signal, 72 seconds, matched precisely what Big Ear should have detected from a continuous transmission by a source at the coordinates from which the signal appeared to come. This was not coincidence, but geometry. As Earth rotates, a radio telescope's beam sweeps across the sky at a rate determined by the telescope's design and the source's position. For Big Ear, observing a source at the declination of the wow signal, the beam would have taken exactly 72 seconds to pass across it. If the source had been transmitting continuously, the signal would have lasted 72 seconds, no more and no less. The wow signal lasted exactly this duration, consistent with a continuous transmission from a fixed point in the sky. The precision of this match added to the signal's credibility as something genuinely from space, something external to Earth that behaved exactly as the laws of physics predicted a celestial source should behave. Taken together, These characteristics, the frequency, the bandwidth, the intensity profile, the duration, painted a picture of a signal that matched theoretical predictions to a degree that seemed almost impossible to achieve by chance. The wow signal was what an extraterrestrial transmission should look like. This match was both exciting and frustrating. Exciting because it suggested the signal might be real. Frustrating because it was not repeated and therefore could not be confirmed. The match remained circumstantial evidence, compelling but not conclusive. Scientists are trained to be skeptical of remarkable claims, to demand evidence that can be independently verified, to resist the temptation to believe what they want to believe. The wow signal challenged this skepticism by providing exactly what theory predicted. Yet without repetition, without the ability to study the signal further, without independent verification by other observatories, the match remained suggestive rather than definitive. The signal was special, but its specialness could not be confirmed. The wow signal became a template for future SETI searches, a model of what researchers should look for, a demonstration that the theoretical framework was sound. Subsequent searches have used the wow signal as a benchmark. If another signal were detected with similar characteristics, the hydrogen frequency, the narrow bandwidth, the appropriate intensity profile, the correct duration, it would immediately receive serious attention. The wow signal established the criteria. Decades of searching since 1977 have not produced another signal matching these criteria, despite vast improvements in telescope sensitivity and computing power. The wow signal remains unique in the SETI catalogue. This uniqueness might mean that such signals are extremely rare, that the conditions that produce the wow signal do not often recur, that we were extraordinarily lucky to have detected it at all. Or it might mean that the signal was something other than what it appeared to be. The telescope that detected the wow signal was never designed to make such a discovery, its original purpose entirely unrelated to the search for extraterrestrial intelligence. Big Ear was built in the 1960s for general radio astronomy, adapted only later for SETI. The telescope's design was unusual, a Krauss-type reflector that used a flat aluminum surface to collect radio waves and direct them toward a receiver. The collecting area was enormous, roughly the size of 3 football fields, making Big Ear one of the largest radio telescopes in the world. Unlike dish-type radio telescopes that can be pointed in different directions, Big Ear was fixed in place, relying on Earth's rotation to sweep its beam across the sky. This design was simpler and cheaper to build, but limited what parts of the sky could be observed. The telescope could observe a strip of sky centered on its fixed declination, different right ascension coordinates becoming accessible at different times of day as Earth rotated. Over the course of a year, much of the sky visible from Ohio could be surveyed. Big Ear was constructed by Ohio State University and began observations in 1963. Initially studying natural radio sources like pulsars and quasars, the telescope contributed to mainstream radio astronomy for a decade before being repurposed. In 1973, the telescope was redirected towards SETI, joining a small number of instruments around the world that were actively searching for signals from extraterrestrial civilizations. The project was led by John Krauss, the engineer who had designed the telescope. The SETI observations were conducted on a shoestring budget, relying heavily on volunteers and students to operate the telescope and analyze the data. Jerry Amon was one of these volunteers, contributing his time and expertise to the search. The computer system that recorded Big Ear's observations was primitive, even by the standards of its time, producing only the simple printouts that would capture the wow signal. More sophisticated analysis was impossible with the available resources. The team that operated Big Ear understood the limitations of their equipment, but believed that even a modest search was better than no search at all. The history of science is full of discoveries made with inadequate instruments by dedicated observers. Big Ear's SETI program scanned millions of frequency channels simultaneously, using a receiver designed specifically for the search. The goal was to detect any narrowband signal that stood out against the natural radio background. The telescope operated day and night, accumulating data that would be reviewed later by human analysts looking for anything unusual. The process was slow and labor-intensive, but it was the best available method given the technology and funding. When the wow signal appeared in the data, it was exactly the kind of anomaly that the project was designed to detect. The telescope and its operators were ready, even if they did not know it at the time. The life of Big Ear continued after the wow signal, with SETI observations ongoing for more than 2 decades following that August night in 1977. The telescope never detected another signal comparable to the first. In 1998, Big Ear was demolished to make way for a golf course expansion, a fate that dismayed many in the astronomical community. The telescope that had detected the most famous SETI signal in history was reduced to scrap. The decision to destroy Big Ear was purely economic, the land more valuable for development than for science. The university had declined to fund continued operation, and no alternative source of support could be found. The loss of Big Ear meant the loss of the instrument that might have continued monitoring the region of sky from which the wow signal came. If the signal ever repeated, Big Ear would not be there to detect it. Other telescopes have since searched for repeats of the wow signal, including instruments far more sensitive than Big Ear ever was. The Very Large Array in New Mexico has pointed toward the signal's coordinates. The Green Bank Telescope in West Virginia has listened. Modern SETI programs, including the Breakthrough Listen initiative funded by technology billionaire Yuri Milner, have included the wow signal's origin in their target lists. The coordinates are considered a priority. Despite these efforts, no repeat has been detected, the original 72 seconds remaining the only data we have. The question of whether a better instrument might eventually detect something remains open. The memory of Big Ear persists in the scientific literature, and in the public imagination, the humble telescope that happened to be listening at the right moment. Its detection remains the strongest candidate signal in SETI history. The story of Big Ear illustrates both the promise and the challenge of SETI. The possibility that even modest instruments can detect something remarkable, and the difficulty of following up on such detections without better resources. Today's SETI instruments are vastly more capable than Big Ear was, able to monitor billions of frequency channels simultaneously and to analyze data in real time. If the wow signal occurred today, it would be recognized immediately, but the signal came in 1977. Detected by a telescope operating at the edge of its capabilities, recorded on paper printouts that were reviewed days later. The circumstances of the detection shaped everything that followed. Big Ear is gone now, its aluminum surface recycled, its site occupied by a golf course. But the signal it detected lives on. 72 seconds of data, that continue to puzzle and haunt the scientific community. The scientific method demands that extraordinary claims be supported by extraordinary evidence, and in the case of SETI, that evidence requires repetition. A signal that appears once and never again cannot be verified, cannot be studied in detail, cannot be confirmed as extraterrestrial. Within days of recognizing the WOW signal's significance, astronomers directed Big Ear back toward the coordinates from which it had come. The telescope scanned the same region of sky, tuned to the same frequencies, hoping to detect another burst. Nothing was found. The telescope continued searching for weeks, then months, accumulating hundreds of hours of observations of the same patch of sky. The signal did not repeat. The failure was disappointing, but not necessarily surprising, as an extraterrestrial civilization might transmit intermittently rather than continuously. A beacon might sweep across the sky like a lighthouse, illuminating any given direction only briefly before moving on. Alternatively, the signal might have been a one-time event, something that happened once and would not happen again, whether natural or artificial. Some natural phenomena occur only once, and some artificial signals might be singular as well. The uncertainty about why the signal did not repeat led to continued searching, with Big Ear monitoring the WOW signal's coordinates regularly for years after the initial detection. Each observation added to the accumulated non-detection. Other observatories joined the search as the WOW signal became famous within the SETI community. The Allen Telescope Array, the Green Bank Telescope, the Very Large Array, all have pointed toward the signal's origin at various times. The combined sensitivity of these modern instruments far exceeds what Big Ear could achieve, able to detect signals much fainter than the original WOW burst. If something similar were being transmitted today at the same intensity, we should be able to detect it. The continued silence from the direction of Sagittarius deepens the mystery rather than resolving it. Either the source has stopped transmitting, or it never transmits towards Earth anymore, or the original signal was something other than an intentional transmission. Some researchers have suggested that the WOW signal might have been a one-time event, even if it was artificial. Perhaps a test signal or an accidental transmission that was never intended to be repeated. Civilizations might transmit only occasionally. The possibility that we witnessed a brief window of transmission, a moment when someone was sending in our direction before redirecting their signal elsewhere, cannot be ruled out. The cosmos is large, and any civilization would have many directions to explore. The lack of repetition prevents definitive conclusions, but does not disprove the signal's potential extraterrestrial origin. It simply means that we cannot study the signal further, cannot gather additional data, cannot resolve the ambiguity through continued observation. The frustration of the non-repetition has led some researchers to question whether the original detection was real, whether something might have gone wrong with the equipment or the analysis. These questions have been examined carefully. The telescope's equipment was checked after the detection and found to be operating normally, with no evidence of malfunction that could have produced a spurious signal. The printout appears genuine. The possibility of hoax has been considered and dismissed, as Eamon and the other researchers involved had nothing to gain from fabricating a signal and much to lose if the fabrication were discovered. Their reputations were staked on honesty. The signal appears to have been real, a genuine detection of something arriving from the direction of Sagittarius, even if what that something was remains unknown. The mystery is not whether the signal was detected, but what caused it. Modern SETI programs have learned from the WOW signal experience, designing systems that can immediately alert observers when promising signals are detected, allowing real-time follow-up before the source moves out of view. If a similar signal were detected today, multiple telescopes around the world would be notified within minutes, directed toward the same coordinates, ready to confirm or deny the detection through independent observation. The protocols for responding to potential extraterrestrial signals have been refined over the decades, with international agreements governing how announcements should be made and how follow-up observations should be coordinated. These improvements cannot change what happened in 1977, when the signal came and went before anyone knew to look for it. The WOW signal preceded the infrastructure that might have confirmed it. The search for repetition continues today, nearly 5 decades after the original detection. The coordinates are included in observation programs, the frequency monitored, the hope of a repeat, not entirely abandoned. Perhaps the source transmits only occasionally, on a schedule we have not yet observed. Perhaps the conditions that produced the signal occur rarely, and we were lucky to have caught one occurrence. Perhaps someday a repeat will be detected, validating the decades of hope that the original signal represented something genuine. Or perhaps the silence will continue indefinitely, the WOW signal remaining forever a singular event. The search persists because the question matters, because the possibility of contact with another intelligence is too important to abandon without exhausting every avenue of investigation. The silence is noted but not accepted as final. The WOW signal arrived from the direction of the constellation Sagittarius, a region of sky toward the center of our Milky Way galaxy, where stars are densely packed and where many SETI researchers consider signals most likely to originate. The direction was not surprising. More specifically, the signal came from near the star group Chi Sagittarii, in a region located roughly 120 light-years from Earth. This distance, if accurate, means the signal would have been transmitted around 1857, during Earth's Victorian era. The uncertainty in the exact coordinates reflects a peculiarity of Big Ear's design, which used 2 feed horns to collect radio waves. The signal was detected by only one horn, that the system could not determine which one, leaving 2 possible origin points in the sky. These 2 possible locations are separated by about a degree, roughly twice the angular size of the full moon, creating ambiguity about exactly where to look for a repeat signal. Both locations have been searched extensively. The direction toward the galactic center was strategically logical for SETI observations, as this region contains a high density of stars, and therefore presumably a high density of potential civilizations. If extraterrestrial intelligences exist, they might cluster in this direction. Big Ear was deliberately pointed toward this region as part of the SETI survey strategy, making the detection of a signal from this direction less surprising than it might otherwise have been. The telescope was looking where signals were expected, yet the specific stars near the signal's origin have been examined without revealing obvious candidates for extraterrestrial civilizations. No nearby stars in that direction are known to host planets, though exoplanet detection in the late 1970s was in its infancy. Modern exoplanet surveys have not focused specifically on the WOW signal's origin coordinates, as the uncertainty in the position makes targeted planet searches difficult. The exact source, if the signal came from a planet at all, remains unknown. The distance of 120 light-years is an estimate based on the signal's apparent location near certain stars at that distance. If the source were closer or further, or if it were between stars rather than associated with any particular stellar system, the distance would be different. 120 light-years is close in cosmic terms, a near neighbor in a galaxy 100,000 light-years across. Signals could travel this distance in the span of recorded human history. If a civilization at this distance transmitted the WOW signal intentionally, they might have been responding to something they detected from Earth. Perhaps early radio transmissions that began in the late 1800s. The timing would be roughly consistent. Alternatively, the transmission might have been entirely independent of Earth. A beacon sweeping the sky, or a message aimed at some other target that we happen to intercept. We have no way to know the transmitter's intent. The possibility that the signal came from something other than a planet orbiting a star cannot be ruled out. Interstellar space contains objects of various kinds, and some of these might produce unusual radio emissions. A spacecraft traveling between stars might produce detectable signals, either intentionally or as a byproduct of its propulsion or power systems. The WOW signal's characteristics do not obviously match any known natural phenomenon. Alternatively, the signal might have originated from some astronomical object we have not yet identified or understood. Something that exists in that direction, but that our surveys have not yet catalogued. The universe contains many phenomena that were unknown before they were observed. And the WOW signal might represent our first detection of something previously unsuspected. This would be less exciting than extraterrestrial intelligence, but still scientifically significant. The region of sky from which the signal came continues to be monitored by various observatories. Though not continuously, the coordinates are included in target lists, observed when telescope time is available. If a repeat signal ever occurs, modern instruments would likely detect it, as long as an appropriate telescope happens to be observing the right patch of sky at the right time. The chances of this are better than in 1977, but not guaranteed. The original coordinates remain a kind of cosmic landmark, a location in the sky marked by that singular event nearly 5 decades ago. Astronomers know these coordinates, reference them in papers, consider them when planning observations. Whatever produced the WOW signal came from this direction, from somewhere in the vastness of space toward Sagittarius, from a location we can point to but cannot fully identify. The direction is known, the source remains. The scientific approach to the WOW signal requires considering all possible explanations before accepting the most extraordinary one. Natural astrophysical phenomena must be examined first, each evaluated against the signal's observed characteristics. Pulsars, the rapidly rotating remnants of massive stars, produce regular pulses of radio emission that can be detected across interstellar distances. When first discovered in 1967, pulsars were briefly considered possible signals from extraterrestrial intelligences. However, pulsars produce broadband emissions and repeat regularly, neither of which matches the WOW signal. No pulsar is known in the direction from which the signal came, and the signal did not repeat in the pattern characteristic of pulsars. The pulsar hypothesis can be effectively ruled out based on the signal's characteristics, which do not match what pulsars produce. Whatever caused the WOW signal, it was not a pulsar. Quasars, the extremely luminous cores of distant galaxies powered by supermassive black holes, are among the brightest radio sources in the universe. They can be detected from billions of light years away and produce strong radio emissions. But quasars produce continuous broadband radio signals, not the narrowband burst that characterized the WOW signal. Quasars do not flicker on and off over periods of seconds or minutes. Their emissions are steady on human timescales. Additionally, no quasar is known at the coordinates from which the WOW signal arrived. The direction points into our own galaxy, not toward the distant quasars that lie beyond the Milky Way. The quasar hypothesis fails on multiple grounds, both the characteristics of the signal and the location of its origin. Quasars cannot explain what was observed. Interstellar scintillation is a phenomenon where radio waves from a distant source are distorted by the interstellar medium, causing the apparent intensity to fluctuate. This process can sometimes amplify weak signals, making them temporarily detectable. If a weak background source were briefly amplified by scintillation, it might produce a signal resembling the WOW detection. The intensity would rise and fall as the scintillation effects varied, potentially matching the observed pattern. However, scintillation would require an underlying source that should still be detectable when observed with more sensitive instruments. Extensive searches have found no such source in the direction of the WOW signal. Furthermore, scintillation typically produces fluctuations on timescales of minutes to hours, not the 72-second duration of the WOW signal, which matches exactly what a fixed source would produce as it passed through Big Ear's beam. Masers, natural microwave amplifiers that occur in certain astronomical environments, can produce intense, narrowband radio emissions. They exist in star-forming regions, around evolved stars, and in other environments where conditions favor their formation. Maser emissions at or near the hydrogen frequency are known, and if an unknown maser existed in the direction of the WOW signal, it might potentially explain the observation. The narrow bandwidth would be consistent with maser emission. However, extensive surveys of the region have not identified any maser source at the signal's coordinates. Masers are typically associated with detectable infrared or optical sources, and none have been found at the right location. The maser hypothesis remains theoretically possible, but unsupported by observational evidence. No maser has been found that could have produced the WOW signal. Other natural radio sources have been considered as well, including radio emissions from planetary magnetospheres and auroral processes around distant stars. These phenomena can produce radio bursts under certain conditions, though typically at different frequencies than the WOW signal displayed. Jupiter produces powerful radio emissions from its magnetosphere, bursts that can be detected from Earth with modest radio equipment under the right conditions. Similar processes might occur around exoplanets with strong magnetic fields, potentially producing detectable signals across interstellar distances. However, planetary radio emissions are typically broadband and variable in ways that do not match the WOW signal's characteristics. The narrow bandwidth and the precise hydrogen frequency argue against a planetary magnetosphere origin. Additionally, no planet has been identified in the direction of the signal that could have produced such emissions, though exoplanet detection was in its infancy in 1977. Modern surveys have not revealed an obvious candidate source. Hydrogen clouds in interstellar space naturally emit radiation at the 21-centimeter wavelength, the same frequency at which the WOW signal was detected. This emission comes from the spin-flip transition of neutral hydrogen atoms throughout the galaxy. The interstellar medium is filled with hydrogen, and radio telescopes routinely detect its emission as they survey the sky. The hydrogen line is one of the most studied features in radio astronomy. However, natural hydrogen emission is diffuse and extended, spread across large areas of sky rather than concentrated in a point source. The WOW signal appeared to come from a specific location, behaving like a point source rather than diffuse emission. Furthermore, natural hydrogen emission is continuous and predictable, not a transient burst that appears once and never repeats. The hydrogen clouds are still there, still emitting, yet the WOW signal has not been detected again. The distinction between natural hydrogen emission and the WOW signal is clear in the data, the signal standing out sharply against the background that the telescope routinely observed. Whatever produced the signal was not ordinary interstellar hydrogen. Some researchers have proposed that an unusual alignment of multiple factors might have combined to produce the signal through natural means. Perhaps a rare configuration of interstellar conditions created a momentary amplification of some weak source. This cosmic coincidence hypothesis is difficult to evaluate because it invokes unknown mechanisms operating in unknown ways. Without a specific mechanism to test, the hypothesis remains speculative. Science generally prefers explanations that can be tested and potentially falsified, and the cosmic coincidence hypothesis offers little in this regard. It remains a possibility, but not a satisfying explanation. The failure of known natural phenomena to explain the WOW signal does not prove that no natural explanation exists. The universe contains phenomena we have not yet discovered, processes we do not yet understand. Perhaps the WOW signal represents our first detection of some previously unknown astrophysical process, something that occurs rarely and produces narrow-band emissions at the hydrogen frequency. This would be less exciting than extraterrestrial intelligence, but still scientifically significant. The systematic consideration of natural explanations is not an attempt to explain away the signal, but rather the proper scientific method applied to an unusual observation. Extraordinary claims require extraordinary evidence. Before concluding that the WOW signal came from an extraterrestrial civilization, scientists must demonstrate that no natural phenomenon can account for it. This has not yet been accomplished, but neither has any natural explanation succeeded. The signal remains in a kind of scientific limbo, unexplained by natural phenomena, but not confirmed as artificial. This ambiguity is uncomfortable but honest. The search for natural explanations continues, as any new understanding of astrophysical processes might illuminate what happened on that August night. The mystery invites ongoing investigation. Each natural hypothesis that fails adds to the signal's mystery, making the unexplained nature of the detection more rather than less remarkable. The WOW signal resists easy categorization. The failure of natural explanations does not constitute proof of extraterrestrial origin, but it does keep that possibility open in a way that would not be true if a convincing natural explanation had been found. The question remains genuinely unresolved. In 2017, 4 decades after the WOW signal was detected, astronomer Antonio Paris proposed an explanation that generated significant attention in both scientific circles and popular media. Paris suggested that the signal might have been caused by hydrogen emissions from a previously unknown comet. The hypothesis centered on two comets that would have been passing through the relevant region of sky on August 15th, 1977. These comets, designated 266P/Christensen and P2008Y2 Gibbs, were not discovered until decades after the WOW signal was detected. Comets are surrounded by vast clouds of gas called comas, which form as solar radiation heats the icy nucleus and releases volatile materials into space. Water ice in particular sublimates and dissociates, releasing hydrogen atoms that form an extended cloud around the comet. This hydrogen cloud could potentially emit radio waves at the 21-centimeter wavelength, the same frequency as the WOW signal. Paris proposed that one of these comets might have been the source. The timing seemed suggestive, as calculations showed that the comets would have been in approximately the right direction in August 1977. The hydrogen coma of a comet could theoretically produce emission at the observed frequency. Paris conducted observations when comet 266P/Christensen returned to the relevant region of sky in 2017 and 2018. He reported detecting a signal at the hydrogen frequency that he interpreted as supporting his hypothesis. The announcement generated considerable media attention, with headlines suggesting that the decades-old mystery had finally been solved. The idea of a natural explanation appealed to those seeking closure. However, the scientific community responded with significant skepticism, raising multiple objections to both the theoretical basis of the hypothesis and the observational claims that Paris made. The first major objection concerned the expected intensity of any signal from a cometary hydrogen cloud. The hydrogen surrounding a comet is extremely diffuse, spread across a vast volume of space. The density of hydrogen atoms in a cometary coma is far too low to produce the kind of intense, concentrated signal that Big Ear detected. The WOW signal was roughly 30 times stronger than the background noise, an intensity that cometary hydrogen cannot easily explain. Radio astronomers who study comets have not observed the kind of narrowband emission that the WOW signal displayed. Cometary hydrogen produces broad, diffuse emission rather than concentrated, intense signals. The physics of hydrogen emission does not support the idea that a comet could produce a signal matching the WOW detection's characteristics. The intensity and bandwidth are inconsistent with cometary origins. The second major objection concerned the signal's duration and intensity profile. The WOW signal lasted exactly 72 seconds, rising and falling in a pattern consistent with a fixed source passing through Big Ear's beam. A comet, however, moves against the background stars, its position shifting measurably over hours and days. This motion would affect how the signal appeared to a fixed radio telescope. The precise match between the signal's duration and what Big Ear should have detected from a stationary source argued against a moving object, like a comet. The geometry did not quite fit. Furthermore, the comets in question would have been relatively distant from Earth in 1977, reducing any signal they might produce to levels below what Big Ear could detect. Distance matters for signal strength. The third objection concerned the lack of repetition. If comets routinely produced signals at the hydrogen frequency, similar detections should have occurred many times as various comets passed through radio telescope beams. No such detections have been reported, despite decades of radio astronomy observations that would have included numerous comets. The WOW signal remains unique. Paris's reported detection of a signal from 266P/Christensen in 2017 was itself questioned by other researchers who could not replicate the observation. The claimed confirmation remained controversial. Different radio observatories pointed at the same comet did not detect the signal that Paris reported, raising questions about the validity of his observations. Independent confirmation was lacking. The comet hypothesis has not been definitively ruled out, as negative evidence is always difficult to establish with certainty. However, the weight of scientific opinion has turned against it. Most astronomers who have examined the hypothesis consider it unlikely based on the physics of cometary emission and the specific characteristics of the WOW signal. The explanation does not fit the evidence well. The attention the hypothesis received illustrates the public appetite for answers to the WOW signal mystery, the desire for closure that a natural explanation would provide. People wanted the mystery solved, yet wanting an explanation and having one are different things. And the comet hypothesis has not satisfied the scientific standards required for acceptance. The mystery persists. The hypothesis did contribute to renewed discussion of the WOW signal, bringing attention back to a mystery that had faded somewhat from public consciousness. Even unsuccessful explanations can stimulate useful inquiry. The debate over the comet hypothesis demonstrates how science works when confronting uncertain evidence. Ideas are proposed, tested against data, critiqued by the community, and accepted or rejected based on how well they explain observations. The process is sometimes contentious and often slow, but it tends toward reliable conclusions over time. The comet hypothesis has been weighed and found wanting by most experts. This does not mean the hypothesis is certainly wrong, only that it has not convinced the scientific community. Future evidence might support it, or might rule it out entirely. For now, the comet hypothesis remains one possible explanation among several, neither confirmed nor completely excluded, part of the ongoing uncertainty surrounding those 72 seconds of data. Beyond natural astrophysical sources and the comet hypothesis, various human-made explanations have been proposed for the WOW signal over the decades. Each has been examined against the available evidence. The possibility that a satellite produced the signal has been considered carefully by researchers seeking to explain the detection. Satellites transmit radio signals as part of their normal operations. However, the hydrogen frequency was protected by international regulation, reserved for radio astronomy and prohibited for satellite transmissions. This protection existed specifically to prevent interference with observations of natural hydrogen emission. Violations of frequency regulations do occur, and the possibility that a satellite transmitted illegally at the protected frequency cannot be entirely excluded, but no specific satellite has been identified as a potential source. The signal's characteristics also argue against a satellite origin. Satellites in low Earth orbit move rapidly across the sky, remaining in a telescope's beam for only a few seconds at most. The 72-second duration of the WOW signal is too long for a typical satellite pass and matches instead what a fixed celestial source would produce. The geometry does not support a low-orbit satellite. Satellites in higher orbits, such as geostationary satellites, move more slowly relative to the ground, but they are positioned over the equator, not in the direction from which the WOW signal arrived. the positions do not match. Deep space probes or other spacecraft at greater distances have been considered, but no mission is known to have been transmitting at the hydrogen frequency from the direction of Sagittarius in August 1977. The possibility of a secret military or intelligence transmission has been raised, particularly given the Cold War context of the late 1970s. Classified programs might have operated outside normal regulations. However, no evidence has emerged linking the WOW signal to any military or intelligence activity, despite decades during which such connections might have been revealed. The hypothesis remains speculation. The signal's characteristics do not match typical military transmission formats, which generally use different frequencies and modulation schemes than what the WOW signal displayed. The match is poor. If a classified program had produced the signal, it would have been an unusual coincidence that it matched so precisely the theoretical predictions for an extraterrestrial transmission. Such coincidences are possible, but unlikely. The possibility of terrestrial radio interference reflected back to Earth from space debris has been proposed as another potential explanation. Earth produces enormous amounts of radio noise. If some of this noise were reflected from a piece of metallic debris in space, it might potentially reach a radio telescope and be detected as an apparent cosmic signal. The reflection would scramble the original transmission. However, the geometry of such a reflection would not produce the rising and falling intensity pattern that characterized the WOW signal. The beam passage signature argues against a reflection. Additionally, the hydrogen frequency is not typically used for terrestrial transmissions, so there would be little to reflect at that particular frequency. The hypothesis has significant weaknesses. Equipment malfunction has been suggested as perhaps the most mundane explanation. The possibility that something went wrong with Big Ear or its electronics to produce a spurious signal. Instruments sometimes fail in unexpected ways. The telescope's equipment was examined after the detection and found to be operating normally, with no evidence of malfunction that could explain the signal. The hardware appeared sound. The data processing chain was also examined, looking for any errors in how the observations were recorded or printed. No errors were found that could have produced the observed sequence. The scientists involved took the possibility of equipment problems seriously and investigated it thoroughly before concluding that the detection appeared genuine. The signal seems to have been real. The possibility of a hoax has been raised occasionally. The idea that someone fabricated the signal to generate attention or to fool the scientific community. Hoaxes do occur in science. However, Jerry Amon and his colleagues had nothing to gain from such a deception, and much to lose if discovered. Their professional reputations depended on scientific integrity. The signal's characteristics matched theoretical predictions with a precision that would have required deep technical knowledge to fabricate convincingly. A hoaxer would have needed sophisticated understanding. The hoax hypothesis has been dismissed by virtually all researchers who have examined the evidence, considered too unlikely to take seriously given the circumstances. The detection appears genuine. The systematic elimination of proposed explanations has not resolved the mystery, but has clarified what the WOW signal was not. It was not a pulsar, not a quasar, not ordinary interference, not a satellite, not equipment malfunction. This process of elimination is valuable even when it does not produce a positive identification. narrowing the range of possibilities and highlighting what remains unexplained. The WOW signal continues to resist explanation, neither confirmed as extraterrestrial nor attributed to any identified natural or artificial source. The mystery endures. The failure of all proposed explanations keeps the most extraordinary possibility alive: the chance that those 72 seconds represented actual contact with another intelligence. This possibility cannot be confirmed, but it also cannot be dismissed. The WOW signal has transcended its status as a scientific anomaly to become something larger, a cultural touchstone that represents humanity's hope and uncertainty about life beyond Earth. The mystery has captured imagination for nearly 5 decades. The signal haunts us because it almost answered one of the deepest questions we can ask: the question of whether we are alone in the universe. For 72 seconds, contact seemed possible. That tantalizing near answer, followed by decades of silence, creates a psychological tension that persists. We came close, or seemed to, and then the opportunity slipped away into ambiguity. The human mind struggles with unresolved mysteries, with questions that remain open when closure feels possible. The WOW signal sits in this uncomfortable space between knowledge and ignorance. The signal resonates with an ancient human hope, the wish that somewhere among the stars, other minds exist, other beings who think and wonder, and perhaps try to reach out across the cosmic distances. This hope appears in myths and philosophies from cultures around the world. The intuition that the universe is not empty, that consciousness is not an accident limited to one small planet. The WOW signal briefly seemed to confirm this intuition. The disappointment that followed the detection was proportional to the hope it inspired. Something remarkable appeared, and then nothing more came, and the silence has continued ever since. This pattern of raised and dashed expectations makes the WOW signal emotionally resonant in ways that a more conclusive detection would not be. The ambiguity is part of its power. The signal has become one of the most referenced events in the history of SETI, appearing in countless books, documentaries, articles, and discussions about extraterrestrial intelligence. Its fame exceeds any other candidate detection. This fame reflects not the strength of the evidence, which remains inconclusive, but the importance of the question the signal addresses. People want to know if we are alone. The WOW annotation has become iconic, that single word capturing the astonishment of discovery, the recognition that something extraordinary had been recorded. Eamon's exclamation speaks for all of us. The image of the printout with its circled sequence and red ink annotation has been reproduced endlessly, becoming a kind of symbol for cosmic mystery. The artifact resonates beyond its scientific content. The WOW signal persists in memory because it represents possibility, the chance that contact might happen, the hope that the universe contains other minds. This hope is not extinguished by the signal's failure to repeat. If anything, the mystery deepens the signal's emotional impact, leaving room for imagination and speculation that a confirmed detection might have closed off. The unknown invites wondering. People continue to discuss the WOW signal, to propose explanations, to search for its repeat, to include it in conversations about extraterrestrial life. The mystery remains alive in public consciousness. The cultural significance of the signal extends beyond the scientific community, resonating with anyone who has looked up at the night sky and wondered whether someone might be looking back. Wherever you are listening tonight, perhaps in a city where light pollution dims the stars, perhaps in a rural area where the Milky Way stretches overhead, the WOW signal represents a question that belongs to all of humanity. The mystery does not require resolution tonight. It simply exists, a question mark in the catalogue of cosmic observations, neither answered nor forgotten, waiting for whatever might come. Some mysteries take decades to solve, and some may never be solved at all. The WOW signal might be either kind, and we cannot know which until the future reveals itself. The haunting quality of the signal is not distressing but contemplative, an invitation to wonder rather than a demand for answers. The mystery can rest comfortably in the unknown. The signal connects us to the vastness of the universe, to the possibility that we are not alone, to questions that have occupied human thought since we first looked up at the stars and wondered what they were. These questions are not burdens but gifts, opportunities for the imagination to extend beyond the everyday, to contemplate our place in a cosmos far larger than ordinary experience reveals. The WOW signal is one such gift, a mystery that invites contemplation, that resists easy answers, that keeps possibilities open that might otherwise close. The haunting is gentle. The signal came once and has not returned, but its memory persists, carried forward by those who wonder what it meant, and whether someday we might understand. In the nearly 5 decades since the WOW signal was detected, the search for extraterrestrial intelligence has continued, with instruments and methods that would have seemed miraculous in 1977. Technology has advanced remarkably. Radio telescopes have grown larger and more sensitive, able to detect signals far fainter than Big Ear could observe. The Arecibo Observatory, before its collapse in 2020, was vastly more powerful than the Ohio telescope. Computer processing has advanced by orders of magnitude, enabling real-time analysis of billions of frequency channels simultaneously. The data processing that once required days can now happen in seconds. The Allen Telescope Array was designed specifically for SETI, with 42 dishes working together to scan the sky. Other instruments have joined the search, forming a global network. The Breakthrough Listen initiative, launched in 2015 with $100 million in funding from technology billionaire Yuri Milner, represents the most ambitious SETI program ever undertaken. Breakthrough Listen uses some of the world's most powerful radio telescopes, including the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia. The program surveys millions of nearby stars. The sensitivity of modern SETI searches exceeds what was available in 1977 by factors of thousands or millions. If the WOW signal were transmitted today, we would almost certainly detect it. Yet the cosmos remains quiet. No signal has matched the promise of those 72 seconds. The WOW signal stands alone in the SETI catalogue. Other candidate signals have appeared over the years, anomalies that warranted investigation and follow-up observation. Each has been examined carefully by researchers hoping for confirmation. Some were traced to terrestrial interference, radio frequency pollution from human technology that managed to contaminate the observations. Others were identified as satellite signals or other known sources. A few remained unexplained, but failed to repeat. when follow-up observations were conducted. Without repetition, confirmation is impossible, and the candidates faded from serious consideration. The WOW signal remains the strongest candidate ever detected, the one that most closely matched theoretical predictions for an extraterrestrial transmission. Nothing else has come close. The ongoing silence has prompted discussion about what it might mean, whether the absence of detected signals indicates that civilizations are rare, or that they do not transmit, or that our search methods are inadequate. The Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them, remains unresolved. The silence is part of this puzzle. Perhaps civilizations are far rarer than optimistic estimates suggest, arising only under conditions that occur infrequently in the cosmos. Earth might be more unusual than we assume. Perhaps civilizations arise but do not survive long enough to become detectable, destroying themselves through war, environmental degradation, or technological catastrophe before they can make contact. Perhaps civilizations exist but do not transmit powerful signals, preferring to listen rather than announce their presence, wary of attracting attention in a potentially dangerous universe. Perhaps they transmit at frequencies or using modulations that our instruments cannot detect. Their technology so advanced that it is invisible to our primitive radio telescopes. Perhaps the distances are simply too great, the galaxy too vast for signals to reach us from civilizations that exist, but are too far away to be detected with current technology. The possibilities are numerous, and the silence does not distinguish among them. We know only that we have not yet detected a confirmed signal from another intelligence. The WOW signal provides a kind of counterpoint to the silence, evidence that interesting signals can appear, that the search is not inherently futile. Something was detected once. This single detection sustains hope during the long years of non-detection, a reminder that patience might eventually be rewarded, that the universe can surprise us when we least expect it. The memory of the WOW signal motivates continued searching, continued improvement of instruments and methods, continued investment in a quest that has not yet succeeded, but might someday. The silence since 1977 is noted, but not accepted, as final. The search continues because the question matters too much to abandon without exhausting every possibility. The next detection, if it comes, might resemble the WOW signal, or might be entirely different, something we cannot predict based on our single ambiguous example. The future is unknown. Modern SETI protocols are designed to respond rapidly to any promising detection, alerting observatories around the world to confirm or deny the signal before it disappears. We are better prepared now. If the WOW signal occurred today, it would trigger an immediate coordinated response, multiple telescopes turning toward the source, data streaming to analysts ready to evaluate what had been found. The lessons of 1977 have been learned. We would not lose the opportunity as we did then, when the signal came and went before anyone knew to look for its repeat. The silence that has followed the WOW signal for nearly 50 years might end tomorrow, or might continue for another 50 years, or might continue forever. The future is genuinely uncertain. What is certain is that the search continues, that resources are being devoted to answering one of humanity's oldest questions, that the possibility of contact has not been abandoned. The silence is not comfortable, but it is not hopeless. It simply reflects the current state of our knowledge, which is incomplete, which might be transformed by the next observation. The cosmos keeps its own schedule, revealing its secrets when conditions align, rather than when we demand them. Patience is part of the search. The wow signal remains unexplained, suspended between the possibility of extraordinary significance and the frustration of insufficient evidence. After nearly 50 years, we still do not know what caused those 72 seconds of data. The signal matched every theoretical prediction for what an extraterrestrial transmission should look like, arriving at the frequency where SETI researchers expected signals, displaying the characteristics that theory predicted. It appeared once, was recognized for what it might represent, and then vanished into silence that has continued to the present day. No repeat has been detected despite decades of searching. This combination of promising characteristics and non-repetition creates a mystery that cannot be easily resolved. The evidence is too good to dismiss and too incomplete to confirm. The scientific community has examined the wow signal from every angle, proposing natural explanations, evaluating human-made sources, considering the possibility of equipment error or hoax. None of these explanations has proven satisfactory. Each fails on one or more criteria, unable to account for all of the signal's observed characteristics and the circumstances of its detection. The failure of alternative explanations does not prove that the signal was extraterrestrial, only that no other explanation has been confirmed. The most extraordinary possibility remains on the table. Science is comfortable with uncertainty, with questions that remain open for decades or centuries, with mysteries that resist the resolution we might prefer. The wow signal is such a mystery. The signal will likely remain unexplained until either a repeat detection provides additional data, or some natural phenomenon is identified that accounts for all the observed characteristics. A repeat detection might happen tomorrow, or might never happen at all. The source, whatever it was, has not transmitted again in the nearly 50 years since the original detection. An adequate natural explanation might emerge from new understanding of astrophysical processes, some phenomenon not currently known that produces narrowband signals at the hydrogen frequency. Either development would resolve the mystery, the first by confirming extraordinary significance, the second by providing ordinary explanation. Neither has occurred despite extensive effort. The open question of the wow signal is not a failure of science, but a feature of honest inquiry. Some questions take a long time to answer, and some may never be answered at all. The signal exists in the historical record, those characters printed on paper nearly 5 decades ago. That annotation in red ink that gave the mystery its name. The evidence is preserved. Future researchers will continue to study the wow signal, to search for its repeat, to propose new explanations, to wonder what happened on that August night in Ohio. The question passes from generation to generation, carried forward by curiosity that does not diminish with time, by hope that the mystery might someday be resolved. The wow signal connects us to something larger than the daily concerns that occupy most of our attention, to questions about our place in the universe and whether we share it with others. These questions have occupied human thought since we first looked up at the stars, since we first wondered whether the lights in the sky might be other suns, might host other worlds, might shelter other minds. The signal does not answer these questions, but it keeps them alive, keeps them present in scientific discussion and public imagination, keeps the possibility of contact from being dismissed. The mystery serves a purpose even in its unresolved state, focusing attention on questions that matter, inspiring the searches that might someday find answers. Wherever you are listening tonight, the wow signal remains part of the cosmic mystery that surrounds us all. The question it raised has not been answered. Perhaps someday an answer will emerge, some explanation that satisfies both the evidence and our curiosity. Perhaps the mystery will endure indefinitely, never to be resolved. Either outcome is acceptable tonight. The question does not demand resolution at this hour. It simply exists, a wonder to contemplate, a mystery to hold gently. The signal came once from the direction of Sagittarius, announced itself with 72 seconds of data, inspired a single word of astonishment, and then fell silent. The stars continue shining in the direction from which the signal arrived. The source unknown, the possibility of contact still open. The universe keeps its own counsel. The night continues wherever you are, and the mystery can accompany you into rest. A question that asks nothing, that simply exists as part of the cosmic unknown. The printout with Eamon's annotation has been reproduced countless times. That famous sequence becoming a symbol for all we do not yet understand about the universe. Big Ear is gone, demolished to make way for development. But the signal it detected lives on in memory, in scientific literature, in the ongoing search for its repeat. 72 seconds from a summer night in 1977 continue to haunt us. A signal that matched our hopes and then withdrew into silence. A mystery that invites contemplation but demands nothing. The cosmos is vast and mostly unknown, full of questions we have not yet learned to ask, full of answers we have not yet learned to hear. The wow signal is one small piece of this larger mystery. Tonight, the mystery can rest alongside you, a companion to sleep rather than an obstacle to it. The question will still be there tomorrow, unchanged, unhurried, unresolved. The signal came once and has never returned. The silence since has been complete. Perhaps someday it will be broken. Perhaps not. Either way, the wandering has been worthwhile. The stars continue their ancient burning, the planets continue their patient orbits, and somewhere in the direction of Sagittarius, the source of those 72 seconds keeps whatever secret it holds. Good night from the Drowsy Astronaut. Sleep well, and we'll explore the cosmos together again soon.